Okay, one type of black hole that sounds really scary to people and is very interesting are the supermassive black holes. So these are the biggest of the big black holes, millions of times more massive than our sun, right? So think about our sun. If we had millions or billions of suns and then we squished them into a tiny point, that would be a supermassive black hole. Okay, so actually, these types of black holes, we believe that they are at the center of most galaxies in the universe. So in our galaxy, the Milky Way, right, our solar system is just one of many solar systems in the Milky Way galaxy. And then there are millions, billions of galaxies in the universe. Okay, so galaxies are pretty large. We think at the center of most of them, there is a supermassive black hole, okay, including our galaxy, the Milky Way. So the supermassive black hole that's at the center of our galaxy is called Sagittarius A star. And this is a computer simulation of the black hole at the center of our galaxy. Okay, and so, yeah, when we think about black holes, we think, well, they're black. You can't really see them in space. But if they are eating things, so if like planets or stars or gas come really close to the black hole, they will get sucked in, basically. And so that's when they light up because you have all this stuff, this gas or the thing that the star was made out of and the star gets ripped apart is circling the black hole, and it's going so fast that it heats up, and that's what makes these black holes glow. Okay, so when they're not eating anything, you can't see them, but when they are, like in this simulation, you can see them glowing because of all that gas going at basically the speed of light. They're going very fast. Okay, so cool little simulation there I wanted to show you. So we think that these came about from other black holes merging together. So we think that early in the universe, 13 billion years ago, there were stars, they died, and then those stars made black holes. So very old black holes. And that over time, these black holes met and merged together. Okay. And they just kept getting bigger and bigger as they ate more stuff, maybe merged with more black holes. And so this is kind of what that is showing, is these black holes eating a bunch of stuff and then meeting each other in space and combining to make a bigger black hole. So watch that picture on the right. There we go, okay? So that's how we think these giant black holes came to be, made from smaller black holes. Not that far in the past, no one thought black holes were a real thing. They were kind of proposed, people had ideas about them, but no one took them seriously. We didn't think black holes were real. Okay, and then Albert Einstein's equations, they led to the existence. We thought, okay, these equations mean that something like a black hole could maybe exist. Okay, but we still didn't really think they were real because we were like, well, for a black hole to form, basically everything in the universe has to be like perfectly symmetrical. for a black hole to form. And that's not really how the universe is. Things are very uneven. Okay, until this guy, Sir Roger Penrose, he was a mathematical physicist. Basically, he did a lot of math and showed that actually a black hole can form. We don't need these perfectly symmetrical conditions. A black hole can form in everyday imperfect life. Okay, so he showed that black holes can exist using math, but we still had never seen a black hole. So we're like, all right, maybe they exist. We don't know 100% for sure. But still, this work showed that and won him the Nobel Prize this year in physics, actually. All right, so he shares this Nobel Prize with two other scientists. And the teams led by these scientists, they had a bunch of other scientists working under them. What they did was they watched about 30 stars in the Milky Way galaxy, and they watched them for 15, 20 years just to see how those stars moved. Okay, and what they found was that these stars were moving around and they were orbiting something that we couldn't see. So usually we think of just planets orbiting our sun, right? But stars actually also move. Whole planetary systems, solar systems, they orbit other objects that are more massive. So you can have stars orbiting something else that's bigger than them. Okay, and this thing that was orbiting it was about 4 million of our suns. So this was proof that there is a giant black hole at the center of our galaxy. Okay. Yeah, so think of a star, right? A star orbiting something even bigger than itself. If there's lots of stars that are orbiting this thing we can't see, then we know there's probably a black hole there, because that's the only thing that's massive enough that could make these giant stars orbit that spot. Okay, and this is the time lapse of one of these scientists, their results. So, like I said, they watched these stars for 15, 20 years, and so each of these dots is a star in the center of our galaxy, and you can kind of see they are moving around something that's there. Okay, so their work is what helped them win the Nobel Prize. So these three scientists together proved that there is a giant black hole at the center of the Milky Way, which is very cool. Okay, just answer the last question and you are done for the day, unless you want to do something for fun. Okay, there's 2 videos after this if you want to learn about the first image of a black hole that was taken a couple years ago, or if you want to learn about something called the LIGO detector that can find black holes. You can watch those videos just for fun. All right, have a good day.